so don't worry about that. But we are going to keep admitting people as they come through, and we are going to get started because we know you are done for the day and probably on your way home or just getting done. This is being recorded, so if you would like to share this with your teammates or re-deliver this at another time, you're going to have access to that. So this will be an on-demand PL session for you. So thank you everyone for joining me this afternoon. My name is Alana Davis, for those of you that don't know me, and I am the K-12 Science Professional Learning Specialist. On this session today, we have the science supervisor, Christian Callie, and also Kelly Bodner, who is the Title I science coach. And my car. Helping me out this morning. So if you could all just go ahead and make sure that you are on mute for me, I would greatly appreciate that. And we're just going to keep letting people in as they hit the waiting room. But I'm going to go ahead and share my screen with you. Oops, I didn't mean to do that. And get started. All right, so today is all about science workshop model and making your opening phenomenal. So we're going to be focusing on that first 10 minutes that you have during your science workshop model time. And as we go through the presentation, if you have questions, please just drop them in the chat. And we have Kelly on standby, who's going to be help me facilitate the chat while she can, and then we'll try to answer as many questions as you have. And like I said, we're going to be developing a whole repertoire of resources for you for science workshop model, and they're all going to be on demand for you. All right, so let's briefly go back over exactly what three-dimensional science is. When we talk about three-dimensional science in the elementary setting, we're talking about transitioning from just teacher-directed science teaching to student-directed science teaching. And the way that we do that are with these three dimensions. We have our science and engineering practices, and that is what scientists and engineers do. Things like asking questions, developing models, planning and carrying out investigations. Those are things that are already embedded within our standards here in Georgia. But we take those engineering, the science and engineering practices, and that's what our students actually do in order to understand those disciplinary core ideas, which is the content piece that you see in orange. And that's what scientists and engineers know. So when we think about our big ideas in science, we think about energy, matter, things in life science like cells, physical science, force and motion. That's the content knowledge that we want our students to have. And then the last dimension are those cross-cutting concepts that help our students make connections across the dimensions. This is how we think. And if we think this way, if we can get our students to think this way, they'll make connections between what scientists and engineers do, what they know, and how they think. And that gives our students the opportunity to make sense of what that little rectangle in the middle is, authentic phenomena and problems. So by utilizing all of these dimensions, it's helping our students make sense of phenomena that we expose them to. So here in Georgia, even though we did not adopt the next generation science standards, we utilized the three-dimensional science approach in our instructional strategies in order to help our students build that foundational science knowledge that we want them to have in order to master the standards. All right, so science workshop model. Let's specifically look at the benefits and what the research says about utilizing the science workshop model approach to teaching. So the research says that scientific literacy starts in early childhood and actually continues all the way through elementary school. And if we want our nation to actually have a scientifically literate society in the future, we need to emphasize the need for consistent science instruction throughout a student's entire academic career. So that developmental process, it takes years of effort to cultivate. So we know that science learning takes time, but that time is not always being provided in the daily schedule that teachers are provided at their local schools. What's eye-opening to me is that a recent study showed that science instructional time is decreasing in elementary school. These statistics, only 20% of K-3 students and 35% of students in grades 4 through 6 have access to daily science instruction. So we know that we need to have science instruction every single day in order to help our students become scientific literate. So why would we choose to use the science workshop model framework? Well, it provides a balance of whole class, small group, and individual instruction to support focused teaching and learning. It includes independent and collaborative work time during the work session. It provides more opportunities for student talk and less teacher talk. So gone are the days when we stand up in front of our students and we lecture them, or we read from the science textbook or the TE about science concepts. We're actually going to engage our students in utilizing and using those science and engineering practices to learn about those disciplinary core ideas using the science workshop model framework. So the structure of the science workshop model is just like reading, writing, and math workshop model. We're suggesting that you have a 25 to 35-minute science block, and within that science block of time, you can do a 10-minute opening, a 20-minute work session where students are rotating through science stations or centers, and then bringing the students back together for at least a 5 to 7-minute discussion, connecting back to the phenomena that you talked about that day. So today we're going to be focusing on that 10-minute opening during the science workshop model. The components for an opening, we're definitely going to want to have our students whole group. You're going to talk about what they're going to learn in the unit or for that specific lesson. So you're going to have a very quick introduction to the phenomenon. You can talk about the learning targets. You're going to model a skill or strategy, and you're going to allow students to pose questions during that time. This is an infographic that we developed for the science workshop model. And what I wanted to point out to you is this opening 10 minutes right here up at the top. During the 10-minute opening, you're going to set the purpose for learning using phenomena. And that way you can assess prior knowledge based on what the questions that students come up with about the phenomenon. You can provide context for new learning, and you're going to model work session expectations. So what does that look like? We're going to go kind of in depth on what that looks like in just a minute. But a teacher will introduce the phenomenon with a video clip, a photograph, a model, a read aloud, and as a whole group, students will help create the guiding question board where they generate questions about the phenomenon. So let's get into this more specifically. So the purpose of the opening, like I said, was to assess prior knowledge, set the purpose and content of learning, introduce a new phenomenon, and model expectations for the work session. So what is a phenomenon? Why would you want to use that in an opening? Well, the way that we suggest that you begin a unit or a lesson in the science workshop model framework is by using a phenomenon, which is an observable event.
I am in this meeting, but I forgot.
Introduced to students in many ways. However, it's best done in a way that captures student interest. As you can see here in these pictures, this teacher has decided to take her students on a nature walk further to introduce the phenomenon. So it's not a one size fits all or a one strategy fits all. It's really based on what's going to capture your students' interest and how they can relate to their experiences with the phenomena, which brings me to this quote here. Phenomena presented in grade appropriate ways are most meaningful when related to students' experiences. Characteristics of useful phenomena include relevant everyday or family experiences, which require students to use core ideas, practices, and cross-cutting concepts to make sense of phenomena. So in 3D science, I love this graphic. I use it in every PL session I do for science. But this is kind of the sequence that we use and how we use the 3 dimensions in our instruction. But it's important to realize that we use phenomena to drive our instruction. What does that mean? We're going to promote vocabulary development through observations and questioning. This is what we do during our opening. We're going to use images, video, real life connections. And then that phenomenon is going to drive our instruction throughout the science unit, coming back to it each day. So the opening you have each day will start with, hey, do you guys remember about the phenomenon we talked about yesterday? And then you're going to go into your mini lesson. You're going to make connections to what we learned each day during your opening by bringing that phenomenon back. Once we introduce the phenomenon, then our students are going to generate questions during the opening, and that's what we call a guiding question board, or you might know it as a KWL or a See, Think, Wonder board. And then after the opening, that's when we release our students to do the work session. So what we're going to do, I'm going to model how to utilize mystery science for a phenomenal opening. So if you're in your car, you're definitely not going to want to do this. But if you're at home or at a place where you can participate, all you're going to need is a pen or a pencil, a sticky note, a piece of scratch paper, whatever you're going to do. Oh my gosh. The power just flickered over here. So whatever. We're just going to keep going with it. Oh, you know what? If anything could go wrong during this first thing, it has gone wrong. Okay, here we go. I'm going to take you to the Mystery Science website. This is an amazing, amazing resource that you have for free this year to utilize for science workshop model. It's video-based phenomenal videos that you can utilize to teach your science content during the science workshop time. The video explorations are kind of lengthy, but if you spread that out through the week, and I'll show you how in just a second, it makes for a perfect opening piece to your lesson every day. All right, if we're going to use mystery science, and I'm going to show you in just a second, we're going to walk through how to use it for a phenomenon. You're going to just show a portion or the whole clip, depending on how long it is, stopping along the way to clarify for students. At the end of that video segment, it's going to give you a discussion question. You're going to allow students time to also create questions for the questioning board. And for our use today, I have a QR code here and a code. So we're going to watch this phenomenon video together. It's going to pose a question to us at the end, but then I'm also going to instruct you to write down questions of your own and put those on our digital whiteboard. Okay, so we are going to hop over. The name of this mystery is How Did a Tree Travel Halfway Across the World?
This is the explorer ship, HMS Adventure, about to set sail around the entire world. On board is a group of sailors. Their plan was to sail from the Hawaiian Islands, that's here on the map, and then circle all the way around the globe, returning back to Hawaii again in under 3 years. The very last thing they had to do before leaving on their journey was to build a figurehead for their ship. This is a figurehead. A figurehead is a large wooden decoration attached to the front of a ship. The crew of the HMS Adventure was excited to carve their figurehead from a special kind of tree found only in Hawaii, a tree the Hawaiians called the koa tree. The wood of the koa tree, seen on the inside when the tree has been sawed, is a beautiful shade of red. Again, as far as anyone knew, Hawaii was the only place in the world where koa trees could be found. And so, with the figurehead carved, off they went on their voyage around the world. They made it across the Pacific Ocean and almost all the way across the Indian Ocean. Everything was going so well until one night, storms created huge 50-foot waves. The force of the waves snapped some of the wooden boards on the side of the ship. Once the storm ended and the seas calmed down, the crew of the ship saw the damage. Entire sections of wood had come off and were lost at sea. Water was leaking in. The sailors were terrified. They needed to act quickly. They needed wooden boards to patch up the leaks. Luckily for them, off in the distance, an island was spotted, and most importantly, There were trees on it. One person on board was especially excited. He was Joseph. Joseph wasn't a sailor. He was the ship's scientist. As ship's scientist, his job was to discover and collect as much as he can, especially about plants and animals that have never been seen before, and then bring his discoveries back to his home country of England. Joseph was excited because this island they were about to land on was a new island. No one had ever set foot on this island before. It was going to be an alien world, and he would be the first to see it. And from the moment they landed, he started seeing all kinds of things he'd never seen before. There were animals he'd never seen before, like this, today called a panther chameleon, or these giant tortoises. Even the flowers and bushes were totally new. There was nothing quite like these in Hawaii. This island that these are on is known today as Reunion Island. You can find it here on the map, in the Indian Ocean, about 1,000 miles off the coast of Africa. While Joseph collected samples, the sailors were busy looking around for the best wood to repair the ship with. They found a type of tree that was large, with sturdy, solid wood. It was perfect. So they chopped the tree down. As soon as the tree fell, Joseph ran over toward its top end to get close to the branches. He wanted to get a look at the tree's leaves and flowers to see if it was something new. Whoa, he thought, these little flowers don't look new at all. They look so familiar. Where have I seen these before? He thought to himself, scratching his head. He pulled out his notebook and realized that these were the same flowers that he saw on the tree that they used to carve the figurehead from back in Hawaii. He walked back down to the tree's trunk where the sailors had cut the tree, and sure enough, when he looked, the wood was red. It was a koa tree. How could this be? Look how similar the trees are. Koa trees are only otherwise found in Hawaii, 10,000 miles away. That's almost half the world away from Reunion Island. That's the other side of the world. How could the same kind of tree be in both places? It's almost as if the trees had flown across the ocean. But we all know trees can't fly. How could koa trees have gotten on both of these islands, half a world apart?
All right, so here you see the discussion question. How do you think koa trees could be in these two different places, half a world apart? It says take a minute or two to come up with ideas that it might explain this. But for our sake, and before I would actually give my students the discussion question, I am going to not show them this screen, but I am going to pause and allow them to come up with their own questions they have about what's happening or how they think this came to be or why they think the trees are here. But we want them to come up with questions. So I gave you a code for our digital whiteboard for us to do that right now. So I would like for you to go ahead and log into our digital whiteboard. You can now access this class by clicking on that QR code or uploading that. And your student whiteboards are going to show up here on your screen with their questions. I'm going to refresh just so we can see it. And your students can type their questions that they have about this phenomenon into the digital whiteboard, or if you're doing this in the classroom and you don't want to do digital whiteboards, what a great idea. What I've seen in some classrooms, and I'm going to give you some examples in a minute, is something called a parking lot, where every student gets a sticky note. They have a student number. You have a laminated piece of chart paper up on your board, or maybe you have it sectioned off on your whiteboard with everyone's student number, and they can just come put their question on their square on the parking lot, and that will be your guiding question board for the phenomenon that you introduced. So it's looking like the questions that I have are not popping up, but does anyone want to unmute themselves and ask a question or share one of the questions that they have about the koa trees? Here we go. Got 4 people now. All right, you can write messages to your students here. You can look at specific students. There's lots of different settings on Whiteboard 5 that you can use. I think none of the questions are popping up. I can give feedback, so I can actually write back to my students. I can list them. I could do a live session with my students to just talk one-on-one with them. I could do quick reactions. I can erase it. I can save it as an image. So this is a great resource to use with your students. How does the koa tree spread its seeds? Great question, C. Richardson. So you can see this is a very interactive discussion piece with your students, because you want to allow your students to share their questions during this opening part that you have after you introduce the phenomenon. This is the most important piece. The questions that the students come up with is going to drive your instruction. So we have a bunch of people getting in now. That's awesome. How big? Okay, Kelly is writing out her question. I love it. How big does the koa tree get? Nice question. So once your students develop their questions, just for sake of time, I'm going to move on, but you can see how to utilize this resource. Once your students come up with those questionings, oh, we're there. So how can you incorporate phenomenon into the science workshop model opening? Well, you could show your students a video. Here's an example of a video phenomenon.
Hi, I'm Scott Kelly, a former NASA astronaut, and I'm on a mission to help your kids learn.
This
While
is the
some use
phenomenon
vicious
video.
weapons to dispatch prey, others employ the finesse of a marksman.
So this is an example. We also have a current event example. So something that's happening in the world right now, an article, a News LA article, or something that you run across on the Science 360 website. Amphibians facing terrifying rate of extinction. You have an experiment or a demonstration. Maybe you want to actually show your students something as the phenomenon so they can figure it out. This is the world's simplest electric train. So this demonstration video is going to be very short. It's 1 minute and 43 seconds, but it's just showing the students a phenomenon. The purpose of showing a demonstration is to get them thinking about how or why something happens. So all of their questions that they come up with will probably start with that. Then we also, like I showed you earlier, Miss Elkins took her students outside. You can use a photograph or a picture, even a read aloud. If you can find a book, a science trade book, to use as your phenomenon, that's perfectly fine as well. The Georgia Science Teachers Association has an amazing phenomena bank that you can utilize. So if you type in georgiascienceteacher.org, you can actually find the phenomenon bank there. You can filter it by grade level, standard, and element. It will actually give you the phenomenon, guiding questions to use with it, instructional strategies, and they will have a link that takes you directly to the original post as well. So what does the science workshop model opening look like? So the first day of the unit, you're going to introduce the phenomenon, and your students are going to create that questioning board. The following days, you're going to review the phenomenon, you're going to talk about it, you're going to come back to it, ask students what they learned the last time you were doing science or the previous day, and you're actually going to allow students the opportunity to answer any questions that they may have on the guiding question board. Here you can see Mrs. Elkins is doing the opening for her students here. And this is day 3 of the rocks unit that she was doing in kindergarten. So I'm just going to let you visit her and see what her opening looks like on day 2 or 3.
Yes, if there's some jewels in them, that's it. You don't think jewels would make it heavier? Yeah. And where does that rock come from? Oh. Volcanoes. Volcanoes. That's what you guys have come up with. You think it comes from? Volcanoes. Who had the volcano rock? At home, they already had one. That's right. Do all rocks float? No. Why? Jacob? Some can float because all rocks are what? Different. All right, now when we talked about rocks, we talked about all the properties, all the attributes, the ways you can describe the rocks, correct? Size. Small. Large. Weight.
So you can see how Miss Elkins utilized the phenomena that she had shown the students the day before of the floating rock. They came up with some whole group questions. This is kindergarten, and we are scaffolding for them, of course. So they came up with some whole group questions, and they're trying to answer those based on the activities that they do during their science centers. The science centers that you do during work session are going to help the students to answer the phenomenon questions that they come up with. So she is using questioning as the key here. So in 3D science learning, the questions drive the instructions. Students should write questions and post them, however you want to do that in your classroom. But here's the most important part. Remember how we talked about our science standards earlier and how we did not adopt the next generation science standards? However, we utilize the science and engineering practices in all of our standards. It's embedded within the standards. So we're going to use the questions that students come up with during the opening to motivate them to obtain answers by researching, investigating, and utilizing those science and engineering practices in their science centers. Then the teachers and the students are going to evaluate their answers as they go to determine if they've answered the question or have even more questions to obtain the answers. And the guiding questioning board allows students to communicate their findings. We know that all of our science standards start with obtain, evaluate, and communicate. And this is how, when we use the science workshop model framework, we can make sure that we're hitting all of those standards. Here are some examples of a guiding question board that we've seen around the district in different classrooms. Here, the teacher has posted a phenomenon question that they came up with together, and students have posted sticky notes answering those questions, and they've added some evidence. Here's a questioning board of all the questions that the students and the teachers came up with together. And another take on that is kind of like you said, our ideas, our questions, and the evidence we got. So that's another example. Here is another way to do it. This teacher has taken her weather unit and broken it down to major themes and topics. And the students are allowed to write down what they know about the topic and then questions that they have. Once they've learned about the specific topic, they can then answer their questions on their stickies and move it over to the no side. Before we wrap up today, I wanted to talk about science, or what am I talking about? Mystery science. So we used the very first video segment to introduce the phenomenon. What you're going to do for the opening, if you're going to utilize a mystery science phenomena for a unit, what you're going to do the rest of the time in your unit. So the next day, you're going to use the next video segment, which is 2 minutes long. That's going to pose another question. And then the next morning or the next time you do an opening, you're going to use the next video segment. And this is going to give them pieces and more information about that opening phenomenon for them to be able to answer those questions and understand how those trees got there. The best part about it, so you have about 4 or 5 video segments, then you have the hands-on activity. And this is what we're suggesting that our teachers utilize in their teacher work session group. So your 10 to 15 or 20 minutes that you have with your students where they're rotating through centers, that mystery science activity will go perfect with that time. All right, so science workshop model lessons. If you need help getting started, we've already created science workshop model unit plans for you. You can find these on CTLS Teach. If you click on your unit navigator, select any of the units in first or second quarter, then you're going to hop down to topic navigator. Underneath that tab, on the Instructional Strategies tab, you'll see the Science Workshop Model unit plans located on the right-hand side where you see all the other lessons that have been posted there before. So if you would like to have us come out and train your team, Ms. Bodner, myself, we are ready to assist you in your school with any kind of PL needs. If you would like us to come just see where you are now and walk through or visit and then assist you in getting started in Science Workshop Model, we are always ready to do that. So all you need to do is contact us. Here are our email addresses. You can check us out on Twitter as well. And we are always ready to be there to help you in any way that we can. So I hope that you have gotten some ideas on how to make your opening phenomenal for your Science Workshop Model. Please check out Mystery Science if you haven't already done so. It's a great resource for our K-5 teachers to use in the classroom. Also, definitely check out all of those phenomenon banks. There's one for the Next Generation Science Standards. There's one for the Georgia Science Teachers Association, and that will help you. At this time, I'm done with the presentation, but if you guys have any questions, you can drop them in the chat or just unmute yourself and ask any questions that you have about it. I apologize for the link snafu. I'll make sure I check all the other links before our next one in a few weeks for sure. All right, you're welcome, guys. I hope you can utilize this resource, and this will be posted to your teams first thing tomorrow. Thanks, guys.